Hi, welcome to Connecting the Dots, the podcast where we share our stories from the battlefield of consulting. I'm your host, Johnny Hill.
I'm Wesley Oberg. I'm a DevOps design lead here and first-time caller, long-time listener.
Hi, I'm Chris Hobson, senior software developer with a focus on front-end JavaScript.
Hi, I'm Bruno Rizzo. I'm senior developer here at Spirit.
Hey, I'm Kareem Jamal, talent dev lead and senior architect.
Today we're talking about refactoring, what it is, why it's important, when it may or may not be appropriate, and some lessons learned and useful tips. Let's get started. So for the uninitiated, what exactly is refactoring?
Technically, to me, refactoring is changing code in a significant way, which doesn't necessarily have an actual change in the functionality for the user, but it's the things you would do behind the scenes in the code, like under the hood and such, mainly to get it to be better code, better organized, cleaner, easier to update or maintain in the future, things like that.
Well, and refactoring goes hand in hand often with what I've heard called technical debt, correct? Like where you're building up stuff that you put together quickly and you know it's not very good and it's kind of held together with duct tape and gum, but you know you have to go back and fix it later. Is that correct that they're kind of related?
I think so, yeah. I think that technical debt is the main reason why you want to refactor a piece of code that is really working. And the problem with the refactoring is that when the code is working, people is hesitant to change it because you don't know exactly what is going to happen. At least you are really diligent with the tests, and the problem that the code solves is not that complicated. I mean, me as a developer, I don't want you to fix the same thing twice or many times. So if something is not broken, don't fix it, basically. But yeah, technical debt, I believe, is the main reason why you want to refactor a piece of code. For example, if you are trying to build something more complex out of a small piece of code that is not really great, you probably want to refactor that small piece of code to make it more extensible, for example. But I think it's always a risk on changing things that are more or less working. So you need to be careful when you're refactoring something.
Yeah, refactoring it is a lot of the time coming from a place of tech debt, but something that I see a lot in especially agile teams is that refactoring is just part of getting a new feature in because you have to pass a new flag through, or you're supporting a new functionality and that requires updating on these interfaces. And that's just part of the work to get that function in a live code base where you're continually merging the master and continually deploying, and you don't want to break everything.
Sometimes you've reached the bounds of what your current system can do, like the choices you've made. They can only do so much, and maybe it's time that if you want to go beyond that, you sort of have to back up a little and do the refactoring in order to be able to scale, whether it's horizontal or vertical, right? So like performance, or be able to service more clients or users at the same time to get around those limits that you're hitting. Sometimes it's you put stuff in and have duct tape and hacks in place. By the way, for the record, duct tape is awesome. Probably the most versatile tape there is. So maybe masking tape is a more suitable thing here, because duct tape can even like hold up a car, and like so I saw it on Mythbusters. But sometimes it's just the limit of productivity you can do, right? Maybe it's slowing down your development team because you have to take 5 steps instead of the 2 or 3 you'd need to take after a refactoring. So there's multiple limits that you may hit that may force a refactoring that then you have to think about and weigh the pros and cons of if it's worth doing now or later, or keep paying the cost for a little bit more before you make the decision.
Yeah, sometimes it's a hard sell too, right? Like refactoring for pure tech debt, or refactoring just for the sake of having cleaner code. So it's more often prompted by the necessity to do it. But I think to do things to do things right, you almost have to build it into the system, like building the notion of tech debt or paying down tech debt, like as part of your scenario, like when you're actually scoping stories or whatever, like when you're actually doing planning, build some of it into every piece of work you're doing, sort of clean as you go type of thing. I think that's the best way to handle this. Like make refactoring part of your everyday life almost, you know?
I'd argue that tech debt is probably the one of the hardest, if not the hardest sell to make, right? As Chris said, it's especially if you're a services company, like consulting like we do, where you tell the user, hey, I'm going to spend a few weeks working and changing stuff. And what change will I see in the UI? Well, absolutely nothing. Your page might load up, 15 milliseconds faster, which is good. But for, spending 3 weeks of cost and time on it, right. But for us, we know how difficult it is. And so you have to sort of come into it with bringing and making the case for it. Because, hey, we can develop twice as fast. We can do so and so, whatever.
Well, yeah, and in some ways it ties back into like estimation, saying, well, putting this new feature in will take this amount of time. Yes, but if we refactor, you'll add that much on the front end, but doing multiple features like this in the future after we refactor will make things go much more quickly. So like there's an estimation element of it too, where you can kind of show your work and say, yeah, it may not seem like it in the short term, but knowing that we're going to have to do things like this again and again and again, kind of simplifying those repeating processes, I think is one way you can kind of help communicate the benefit.
And the hesitation from the client or the user side is well-founded, because I will tell you, as a dev, all devs want to refactor all the time, right? Because there's always a better way to do it. You can build something last week and now you see a new library or a better way to do it, and you want to go back and refactor. Or as is the common case, you take over from a different dev, and of course, everything they did was wrong. So you have to refactor everything now and build it. And so that's why there's a hesitation where, is it because a developer just wants to do it, or is it really necessary, right? And finding that balance. And that's why you have to sort of make the convincing argument and show your results.
Well, and even knowing like there's probably a point where, yes, okay, say the customer is happy to put in the time and the money to refactor, knowing when enough is enough. Because like you were saying, there's always stuff that could be better. There's always things that could be cleaner or faster or more efficient. Knowing where's the cutoff to say, okay, that gets us to where we need to be. We could go farther, but it's diminishing returns at that point.
You can always go further. You can always squeeze out 2 or 3 more milliseconds each time, but it's not worth it, as you said.
Right.
Yeah, that's a hard problem to avoid for me. I tend to go too deep on those kind of things. So I was thinking on something that you said, Chris, about planning around the technical depth. And for me, that's a key differentiation between a senior developer. Like a senior developer or architect know exactly how to navigate like the technical depth that you can take on the code base to move faster, but not compromise the whole thing. And that is kind of tied to what room you left for refactoring. So if you are planning, okay, I will not go like, I will do this part of the feature, like a little duct tape it, so I can move faster to other things that I need to show or get to unblock other people in the team. But I know that the fix for that is not that complicated, or that I can fix that without breaking everything else. So I think that's a really complex problem. And so yeah, you need to think about that when you think about refactoring.
Yeah, I like that. Like know where to put your real focus into and where you can kind of gloss over just for now.
Yeah.
It's huge.
And another thing to keep in mind, just like any other estimates we do, the estimates we'll put in for refactoring are going to be off, and it's likely going to take double that time too, which, just increases the hesitation that people have, because it's like, oh, you told me this was going to take 2 weeks, but it has taken 4 weeks now. So I don't want to do refactoring again, type thing. And we have a podcast for a episode for estimation if you want to visit that too.
Well, and even thinking about it, in that episode where we talked about estimation, I know one of the big takeaways we had was like write everything down. So from the estimation side, it was, yeah, write it down so you have a record for later. But in refactoring, like, and you were saying, talking about like keeping track of technical debt, like having a record you can go back to and saying, yeah, these are all the things I know we need to go and fix later, instead of like, I don't know, it's in there somewhere, it could probably be faster. Like keeping on top of stuff to some extent so that you know where to focus and where to put your energy when you do have that opportunity to make things better.
Yeah, I think we've kind of said in a couple different ways that you need some focus and some intent when you go into this. Otherwise, it could spiral out of control and become a rewrite.
Mm.
Something very different and much more nebulous and scary.
We've talked about tech debt and how to approach it, but maybe we can also talk about how we end up in that situation in the first place, right? What things lead up to us having to do a refactor or have accumulated that much tech debt.
Yeah, I mean, in the ideal world, you wouldn't ever have to refactor because you just write code perfect the first time. You know? I mean, there's certainly things you can do to stave off, like, you know, clean code, readable code, building things right, modular, flexible, extensible, right? But you're gonna have to eventually. But you know, again, just common hygiene, like doing really good PRs on the team or reviews, I mean, code, and having standards between developers and things like that. All these things can help, again, to limit the amount of refactors that you'll end up having to do. Of course, huge is testing. You know, it goes hand in hand with refactoring is unit tests. Having those written can give you confidence when refactoring as well. So that's huge.
Yeah, that's kind of key, right? I'm not sure if I I'm not sure if I will refactor like an important piece of code without test. I probably start writing the test and then do the refactoring if they are not in place, because you never know what's going to break.
And you should factor in those tests as part of your estimation too. So sometimes you just end up in that situation organically, right? So when you started off, you were designing for a set number of users, right? We're going to have 100 users or 1,000 users in the system. And at that early stage, when you're just getting going, trying to design a full enterprise solution that supports, 500,000 users a second type thing, this doesn't make sense. You would go under if you try to do that and never succeed, right? And so sometimes it's just, that's part of the plan, right? You do this once you get to that limit where you need those hundreds of thousands of users at any given time, then you have to do a refactoring to now change your architecture to be able to support the increased scale.
That's an interesting point. I feel like oftentimes refactoring can be thought of as like the result of something negative, like, oh, we didn't have enough time, we need to go back and refactor. Or, oh, something went wrong, we need to go refactor, instead of a metric for success. Like, yeah, this product is working well, or we have more users than we expected, or things are growing and getting, we need to support the new features or new users who are coming in, that kind of a thing. And it can be a sign that things are going well and seen as like an investment in that growth, instead of like, oh no, we didn't do enough work on the back end. Okay, we need to go fix and clean up our mess, kind of a thing.
Yeah, I agree with that sentiment that it's not necessarily a bad thing to be talking about a refactor or even tech debt. It's, bit rot is real. Libraries, become unmaintained. You will, as long as you have software that you care about, you will be working on it, and that will be refactoring. And that's just the tune-up of the car that is software.
Yeah, good point.
I mean, we should start a branding campaign like, hey, refactoring, sign of success. Like Milk did with the Got Milk billboard and stuff. That's absolutely right. If we can say like, hey, you're doing well, that's why you need to refactor, and present that in that way and make the case for that, that will help the case and the other side accept and sort of be willing with you to say, yeah, now is the time to do it because we've been so successful.
Yeah, it's not always that, but it can be that it's a sign that you're about to level up, you're ready to level up, but you have to, go run that last mile to actually get there.
So I think there's also an element we need to talk about. Like there are times when refactoring is not appropriate or it's not a good idea, maybe in a specific point in time, or just like it's not the right focus at, for a specific area you may want to have the desire to refactor. So I don't know, I'm curious, talk me kind of through when or how to know when refactoring is a good or a bad idea or when it's the right time.
It's not a good idea a week before the deadline.
And it's not a good idea without any tests. Like if you can't verify the state, you're transforming it into something else you can't verify, and it's going to drift.
And it's not a good idea when you are presented a very legacy code base that's essentially built and done, and the effort of refactoring would take longer, or as long, if not longer, than building it from scratch, like throwing it out, redoing the whole thing.
Yeah, I think that's why there are many systems still using legacy implementations, right? I know of many banks that still use Fortran, for example, or COBOL. It's because they don't exactly know what's happening. So instead of changing whatever you have, it's safer to start building a new stuff and migrate operations one by one instead of changing anything of what the current code is doing, because no one really knows what's behind those code base. So yeah, sometimes it's not an option, basically.
So there are ideal conditions under which refactoring makes sense, but when you're outside of those conditions, there's a lot more risk than you might expect.
Yeah, talk me through some of that, because I was going to ask, like, there are obviously risks in place for if you don't have tests set up, but even if you like set everything up right and there's a need to refactor and there's budget for it and there's resources and all that, like there's still risk there. Like there are things that could go wrong or things that could balloon out of control, right?
Yeah, it's hard to sometimes it's hard to predict what's going to happen, even if you have tests or a certain amount of tests. Things can go off in weird ways sometimes. And the only thing that you can do is just plan for those situations and try to mitigate when that happens, basically, and have a good plan to deploy the changes and measure the impact of what you are refactoring. It's not I don't think that it's a 100% safe way to do this. There are plans to mitigate it. For example, having tests is a must, I guess, but it will not cover all the cases that you will face. For example, you can test in isolation with your piece of code, but you would put that on the real world, interacting with other stuff. You always have a room for something to go wrong that is not on your tastes or on your ideas of what can happen. So I believe that the only thing that you can do is just plan around that, test your changes carefully, and see if that it plays well with the rest of the system, for example.
Yeah, that's great, the rest of the system, because in my mind, the most brittle part or the most risky part are all the interfaces with everything else. And so like if you're talking about, hey, we're upgrading to, a new unified Cassandra driver and it's got a slightly different API in some cases, well, I hope, those new APIs support everything you use, right? And so it's like, if you know some of the components that you're trying to go towards with this refactor, do a spike real quick and see like, hey, do the patterns we normally use actually work with this new thing we're talking about refactoring towards?
Speak like you've had that experience before.
Was that too specific?
Yeah, that's a great idea. I like the idea of planning out the refactors. So looking at the whole thing, looking at the risks, de-risking, spiking things, making sure that the trouble spots are, figured out kind of ahead of time before you even begin. And then there's the notion of you have this giant thing you want to refactor, but can you break it into smaller pieces? Can you say, okay, we're just going to refactor this part, we're going to stabilize the code base and make sure it works, and then move on later to the next parts, chunk it into pieces. Defining
the scope and sort of limiting yourself to that scope is, I think, important. And saying every time you hear refactor, it's like, oh, this big thing, all development will stop. And we're changing out the core and stuff. No, there can be some refactorings off to the side, or maybe you're changing out this one side component of it. you're not always changing the transmission of the car while it's driving, right? Sometimes you're just, fixing the rear view mirror, or, doing a paint job or something like that, right? And so those are enough to be called a refactoring, but it doesn't mean that it's, everything will break all of a sudden, or everything will stop. So it helps to define sort of the blast radius of the refactoring you're doing.
Are you describing microservices?
I could apply to anything really, but yes.
So it's something like this on the design world, Johnny. Like if you have, because the refactoring that we're talking about is kind of transparent to the consumer, but in the design, can you do that?
It's interesting you mentioned that, because that's something I was already kind of thinking about, and it's similar. It's the kind of thing that doesn't directly affect the end user at all, but there are times where definitely, like, a good example is leveraging things like repeatable components and symbol libraries. Getting that kind of a thing established and built at the very beginning of a project is ideal, because say there's a button style that I'm going to be using in 50 different areas. Rebuilding that every time, or copying an old version and tweaking it every time, you're going to start to get issues that kind of percolate throughout the whole thing. But there are also times where, oh, well, the software I'm using came out with an update and now they support color variants. Oh, okay. So should I take the time now in the middle of the project, right before this deadline, to go back and make sure all of my button styles are using the same color variant, so that if I make a change, it goes and applies to everything? Okay, probably not in the middle of the project, but finding a time, knowing when it's an appropriate space to kind of set aside and do kind of that more construction of how the file is built out and how the components are constructed, so that everything can scale and work out. If I make changes, it applies to everything. So it's definitely similar. And as you guys were talking about that, I was thinking through, there's definitely times and reasons you can't do that. But everyone would agree that if I have a file that's set up with like very flexible and responsive symbols that I can use throughout the whole system, like that's going to make everything go way faster. So it's definitely similar. And I can definitely see like the kind of correlations between the technical and the user experience roles when it comes to things like refactoring.
And can you break it when you're refactoring such a thing?
Oh yeah.
Like...
it's definitely different, but yeah, like if you do the wrong thing and you're trying to make like a button resize based on the how long the label is, and that symbol is already applied elsewhere, yeah, you can totally do it wrong and break it, and then you don't even realize it for weeks. So yeah, it's definitely different, but there's enough correlations to where it's like, yeah, I can kind of relate to the drama that you guys feel with wanting to fix things and knowing you might break more things than you fix.
Yeah, I can see it. But you don't have like tests, like automated tests to see out like on the spot that something is breaking.
It depends. Yeah, usually not to the extent that the development world has. Often it's more like, oh, I noticed this thing broke. You're not really going to get an alert when a component isn't functioning how you thought it would. It's probably functioning how it's supposed to, and you just set it up wrong.
Yeah.
Well, I'm curious. Obviously, I'm the outsider here looking into the technical side of refactoring, but I guess I'm just kind of curious, like, what are the things that y'all have learned maybe from, the first time you had to do a refactor going along to like the most recent kind of refactor work you've done? What are the lessons you've learned, or the things you've observed, or the mistakes you've made that you wish you would have known for that first refactor?
Mistakes. I mean, this is only a 20-30 minute episode. So how much time you got? Risk mitigation is one important thing for you and for the user and the client. So we talked about one where it's limiting the scope of the refactoring, right? That way, if things don't work out, then it's not affecting the whole app, right? The whole system. The technical spikes we talked about, that's another way of quickly getting some answers before you go all in on the refactoring and see if this is even a feasible approach or not. What these things also enable is parallel development, right? So if you if you have a backup plan where the core app or the main functionality is still proceeding forward and you can continue development, and you're sort of doing this in a parallel path where when it's ready, you can start integrating and swapping it in. That really reduces the risk. That way, if there's time overruns or things just don't work out or performance is not really what you thought it would be, it's not holding up your project, and all of a sudden your deadlines are now way out in the future. You can still continue and sort of abort that refactor or keep working on it outside of the timeline pressure.
Yeah, even if you have really good tests, sometimes they're only there to signal 200 red dots because your refactor had to break them all. And that the point of the refactor is to, break it and then go fix everything, guided by those tests. And maybe this sort of is related, but just kind of on a more personal note, but like a kind of a personality. I find that like perfectionists that like don't like to share their code until the PR is just perfect and ready to go aren't going to do as well on a refactor, because the point of it is that you're breaking things and you need to be open and collaborative.
Yeah, talk through some of the collaborative aspect of it, because I mean, obviously, in this kind of a work, you need, you can't be off on your own trying to fix everything, and there's going to be stuff you miss. But talk me through, like, what does the collaboration side of refactoring look like?
Well, there's the setup to it, right, which is kind of all agreeing on what the plan is and who's going to tackle what and how we're going to come back together. It's it's no different than any other software process, right? It's like we're going to go write something. It just happens to be something we already wrote last week or something, and now we're refactoring it or whatever it is.
And having daily stand-ups and status updates is important, because if, say, you're doing the parallel tracks, right? If someone is changing something in the core that's really going to affect the refactoring you're doing, or vice versa, then when it comes time to converge again and integrate, you're going to have a lot more headache to deal with and conflicts. If this important things on the core side were changed out, or there were different assumptions made that are now broken all over again.
Yeah, and around the planning and seeing with the team, I think that probably the thing that is different for a standard feature development is that if the refactor takes like multiple steps, you need to agree with the team, like, hey, this is going to be broken for, I don't know, a week or a sprint.
And you asked about lessons learned, and for me, one of the lessons learned is actually to resist the temptation of refactoring. A lot of us approach our work and we want it to look nice and clean, like a work of art, right? And that's why we often want to refactor and just make things clean and performant and just nice looking overall. And we come in and immediately start thinking that way, and I have to change this and I have to change that. But oftentimes you don't really need to in the grand scheme of things. It's good enough. You don't have to make it perfect, right? And so just being able to resist that temptation and know yourself to know you're going down this rabbit hole when you probably shouldn't be. You should be spending your time elsewhere.
Yeah, exactly. I'll double that. I mean, to have the self-awareness to like, okay, you've gone too far, go back, like as a early junior developer, like you have to kind of learn that, it's not something that you instinctively have when you're trying to like figure a problem out. You're so sucked into the problem itself and making things better that you got to step back and look at things holistically and say, okay, what's the point of actually doing this? Is it necessary? Is it to waste all this time, or do you spend all this time doing it? Or or will this work for now, and then we can move on and work on something more valuable, instead.
Yeah, that for me is a constant fight with myself. The thing that I trying to learn and still fighting this is when something is finished. When I'm working on a task on a project for a client, I have like a clear deadline that is more or less my estimation. So if I'm getting too close to the day that I say that I'm going to deliver something, I just try to get things sorted out.
That's a good point. Time boxing is a good strategy, because your work will expand to fill the time available. And so if you limit it, then you are saying at the end of this, I will make a decision on whether I continue or not. Otherwise, I'll keep going down this path endlessly.
Yeah, that's pretty dangerous.
It also helps to know sort of what you're building for, right? So if you're building a product, then refactoring has a different meaning than if you're building a quick POC, right? The POC doesn't have to be perfect. It's trying to prove a concept. And so it doesn't have to all be perfect. The important thing is getting the idea across so it can be communicated and seeing if there's interest to move forward to an MVP and a product, right? And yes, there is always going to be a challenge when you give a POC and then immediately people like it. And it's like, okay, we have the code built, right? Let's take it to production now.
Add this feature.
Yeah, exactly. And we actually talk about that, I think, in our very first episode of this podcast. But like, there's challenges there and communication needed there. But just being aware of the context in which you're operating and the goals, technical and business goals, is important and helps you make that decision one way or another as well.
Kind of a different side note, but it made me think of, as a team, not being worried about throwing away code either. Like, don't be scared about just, okay, we're going to delete this whole thing. Because I mean, sometimes it holds you back, having existing code, whether it's a POC or anything, just, it's sometimes faster to just throw everything out, move forward, or throw a piece out and move forward. So not so much refactoring, but yeah, it's good to not be too married to any one thing that we build in general, Did have a question for the panel. Do you folks use any kind of tools for refactoring, like extensions, plugins that aid in the process?
Man, that kind of depends. If it's a really big enterprisey style project with lots of, class accessors and stuff like that, sometimes just running sed recursively over the thing to rename things or kind of, go down and find some mechanical changes you can do there. And then at least you've got a dirty Git that you can open up and kind of navigate to those and kind of target what you're looking at it across a giant code base that, it may be in 4 different modules and that build different DLLs. And you just need to find all those points to even start the thing.
From the UI side, it's similar to testing in that using tools that simulate different browsers and, devices and aspect ratios and all that, responsiveness overall, just to see that has your new design broken anything in there or not.
I certainly never used it that those operations like extract as a property or move parameter to a function. So those automated operations on some IDEs, I never use those. But I think my approach on automation on refactoring is more like Wesley was describing, like find a pattern of changes that I can automate with a complex replace, for example, and just apply that and see and expect it to be broken when I expect it to be. So and work from there. Probably that's my main tool.
And then one thing that we sometimes use, though not too often, is just deploy to production and let the users tell you.
That's the faster one.
Not advisable, but great for getting results.
Right. It really tells you if the clients and users are actually using your system, and it's more of a test of if they're engaged or not.
You'll learn their tolerance for broken stuff too.
Exactly.
Well, let's wrap it up here, and we can just kind of roundtable, quick summary, talking through kind of some of the things we learned and talked about today.
Talked about what refactoring is, changing code to reducing tech debt, making it better without necessarily introducing features or value to the user. We talked about pitfalls during refactoring and how to do it well.
Yeah, probably try to have like a good set of tests, at least a minimum. And if you're planning to refactor something because you thought that there is a need, just plan around that. Try to minimize the changes and be clear about what the expected outcome is. and try to focus on that instead of going on and on the refactoring.
And understand your context so you get a feel for when it is appropriate and when it isn't.
Thanks for connecting with us today. If you have a complex software problem that needs solving, thoughts on what we discussed today, or ideas on what topics we should tackle next, feel free to reach out to us at podcast@experoinc.com or on Twitter @experoinc. We'd love to hear from you. Thanks again for joining us, and we look forward to connecting with you next time.